All right, let me set the context for the video. OpenAI recently released a new open source project called Codex. It's their answer to Claude Code, and it is open source, which gives us the opportunity to contribute to it. It was originally written in TypeScript. They are now migrating it over to Rust. All of this happened in a span of 10 days. So I wanted to contribute to this project originally in TypeScript. But today, we'll look at the TypeScript code base, then we'll go through the Rust code base, then we'll try to understand how can we contribute. I've figured out a few features and issues to fix. We'll try to fix one of them. I also have two more at the back of the head that I might fix on GitHub or in a live stream. We'll figure that out. The things to learn over here are number one, agents. Effectively, what they've built is a terminal in which you can ask OpenAI or ChatGPT to do something. And ChatGPT will not just respond back with text, it will also give commands to run on your local machine. That's close to what an agent is. So how does that happen? Number two, how do you build CLIs that look pretty in Rust? I repeat, command line interfaces that have a very specific UI. How do you build that in Rust? That's a challenge, and that's primarily where we'll be contributing today as well. Other than that, some basics of Rust I've covered. How do you structure projects? What is a cargo workspace? There's a lot of scope to contribute here because there is a TypeScript repo that works fairly well. There is a Rust repo that they're slowly trying to make feature compatible with the TypeScript repo. And hence, there's a lot of scope of contribution. That said, only if you understand what you're doing is when you should contribute. That's pretty much the context on this one. Let's get right into the video. Alrighty, let's get right into it. The code base that we're contributing to is Codex. It was introduced, I think, last week or so. Here is the launch video from OpenAI or from Fireship if you're interested in it. This is the OpenAI launch video. I was in the US when I saw this. So I wanted to contribute to this, did not have the time. I opened the repo back like 10 days ago and I realized the code was in TypeScript. So I was like, beautiful, would be a great contribution to make. And then today, when I opened their code base, I realized that they are migrating over to Rust. So they already have all of this code that you see on the screen. That's mostly in TypeScript. If you go to Codex CLI, this is where primarily the code resides. But you will notice they have a new folder called Codex RS that intrigued me. And when I opened it, I read through the docs and it said on April 24th, that's like 4 days ago. Today, it is written in TypeScript for a number of users. Runtime inhibits adoption. They would be better served by standalone executables, which is something a Rust or a C or a Golang would provide you. As maintainers, we want Codex to run efficiently on a wide range of environments with minimal overhead. We also want to take advantage of OS-specific APIs to provide better sandboxing. All of this makes a lot of sense. This was the reason I was very surprised. Why did they pick TypeScript in the first place to write this on? And hence, today we'll be trying to contribute to their Rust code base. Thankfully, there are a bunch of pitfalls here. It's not yet compatible with their TypeScript code base. And hence, there's a lot of room for, contributing. That said, video comes with disclaimers as always. Okay, don't contribute if you don't understand things, even though I'll try my best to explain everything that I'm doing. It's the worst idea in the world to contribute a simple one-line change unless you think you're providing substantial value. Just try to read through the code base or maybe use the tool. Do not try to contribute. Unless you're really good, in which case, go for it. With that, let's get right into it. Let's understand what is the Codex CLI. We'll try the TypeScript CLI first, then we'll try the Rust CLI. We'll try to find some differences. We'll try to contribute to it. Let's get right into it. All right, let's set up the project locally. Let's try to run it and see what it does. I've already cloned the repo, would urge you to do the same and open it in the editor of your choice. I've opened it in Cursor. And as I said, there are two folders here that are interesting, the TypeScript implementation and the Rust implementation. So let's try to run the TypeScript implementation first. If I go to codex-cli, you'll notice it has a bunch of folders, a bin folder that compiles the final binary. So if you look at codex.js, it'll spit out a final binary, or this is the final file that you run eventually in production. Source has all of your final source code. Notice it has an app.tsx, so it somehow renders React components in the terminal. There are libraries that let you do it. Let's not go too deep into the TypeScript code base because anyways we'll not be using it. They've deprecated it as well, but let's try to run it. So pnpm install followed by pnpm run build. And once you build the project, you can run dist/cli.js. And unfortunately, it will not work if you don't have an OpenAI key. So you can get one from platform.openai.com. You might need credits as well. I think for testing purposes, you might not, but if you eventually want to use the product, you will need some $1 of credit at the very least. So yeah, you need a credit card. For the issues we might be solving today, you might be okay. We might not have to interact with the LLM. But in the worst case, yeah, you will have to, wow, you can actually see the LLM calls here. You will have to put some money in here, and once you do, create an API key from here. I have already created one for my OpenAI account. I also have $10 in there. You will have to pass that in as an environment variable. The easiest way to do that is to export your API key in this environment variable called OpenAI underscore API underscore key. What this will do is this environment variable is available in this terminal from now on. And now if I run disk/cli.js, you will see a command line interface that opens. This is their final product. What is the product? It lets you talk to an LLM to describe the current project, make changes in the current project. For example, I can ask it to, I don't know, what's the simplest thing we can do here? I guess explain the project. So what this is going to do is it will talk to the LLM, and the LLM will tell it to, do a bunch of things. For example, let's just see what it does. The first thing the LLM asks is to run the command pwd to see the current working directory. Then it asks to run the command ls-r that will list all the files that exist in this folder, so on and so forth. This is the LLM gathering context of the repository before it gives you the final answer of what the project does. I can ask it other things, edit a file, add a feature, so on and so forth. So think of it very close to a cursor or event serve, only it runs directly in your terminal. Cool. We'll wait for it to finish, then we'll proceed. Cool. As you can see, this is the final response from the LLM. It's a comprehensive response. This repository is the source code of Codex CLI, a terminal-based agentic coding assistant built on top of OpenAI's LLMs, so on and so forth. So you get the idea, you get what the product does. Not the first product to do it. A lot of Claude Code does the same thing. There's another project called 𝗟𝗶𝗀𝘀. There were a few others before this. GPT engineer, I think, that did the same thing. Only this one is by OpenAI. Unsure if that changes anything functionally. But this is their, open source product that lets you edit code. Cool. This is the TypeScript implementation. Oopsie daisy. We don't want to look at that. We want to look at their fresh Rust implementation. I'll take you through the code base soon enough. But before we do that, let me go to codex-rs. And this is all the source code in Rust. So basically whatever is present over here is what's present over here functionally, even though the Rust repository is slowly becoming feature compatible with the TypeScript repository. So it's not complete yet, but you have a minimal product working. So there are a few folders here. I'll first show you how to run it, and then I'll explain what the folders do. But if you go to TUI, so that's codex/rs/TUI, that stands for terminal UI. And if you run cargo run, I guess before that you need to, this is a new terminal. So I need to export the OpenAI key again. There we go. And now if I run cargo run, assuming you have Rust in your machine, this will start the project locally. Let's wait for it to happen. There we go. So we see a very similar UI. You can build CLIs in TypeScript. You can build CLIs in Rust. You can have a fancy UI for a terminal in TypeScript. The same is true for Rust. And hence, you see a similar interface. You can ask any questions similar to the one that we already asked in the TypeScript project. Explain the project to me, or make some changes in it. I don't know, make the UI prettier, whatever you want it to fix in the current project. So since I'm running this in Codex RS repository, it will try to fix the Codex RS repository, but you can run this CLI anywhere in different project, and when you run it in a different project, it will fix that specific project for you. So if I run the command make the UI prettier, it's basically going to talk to an LLM. The LLM will try to gather context of what this project is, what it does, and make the UI for the project prettier, which basically means we're using Codex RS to make Codex RS prettier. You get the idea. The project is sort of fixing itself, which is a very cool thing to do. We'll wait for it to happen, and then we'll proceed. All right. So it responded. Don't think it ran any commands. And that's maybe because the Rust implementation is buggy. I do see it suggest a few things. pretty coming different things for different people. So start, okay, so just asking me a follow-up question. Do I want to do this? Do I want to do this? So on and so forth. I don't want to do anything right now. I just wanted to show that it does something similar to what the TypeScript project does. So we understand what the project does. From this point onwards, we can pretty much ignore the CLI. That's the TypeScript implementation. Let's focus on the Rust implementation. Let's see what all features are missing over here compared to the original implementation. Let's go through some of the issues and try to understand the code base, I guess. Step one is, let me take you through all of these modules. What do they do? My understanding of them, and how do you build a monorepo-like structure in a Rust project. Alrighty, let's explore the project. I haven't looked at it too much until this point. What you see over here is what's called as a cargo workspace. It's closer to a monorepo or a turbo repo in Rust. Basically lets you structure your project in various other packages. So if you look at the top level cargo.toml, you will see it says workspace over here. That means this is a root level workspace. It's like a monorepo in TypeScript. And these are the members or the packages that this specific monorepo has, or the specific cargo workspace has. So that's apply patch, ANSI escape, CLI, core, exec, so on and so forth. So these are the packages of the project. Generally a good idea if you have a very big project to break things down into smaller packages. And if you look at any of these projects, let's open CLI over here and try to explore cargo.toml. You will notice some of these are binaries and some of these are libraries. So quick Rust jargon before we proceed. Whenever you're starting a new project in Rust, oopsie daisy, you can either create a library or you can create a binary. These are the two things you can do when you're starting a new Rust project. When you create a library, that means you are creating, well, a package or a library for other people to use. So you don't have this never executes independently. This is just, it just has a top level lib.rs that other binaries import. So if you're ever creating something that needs to execute, then you create a binary in Rust. If you are ever creating helper packages that other binaries are going to use, then you create binaries. Do you get the idea? How do you initialize a fresh Rust project? Let me quickly show you. KDIR Rust project CD. The way you initialize a Rust binary is by running cargo init. This will initialize a fresh binary. So if I run this, you will notice I have a source/main.rs and I can run cargo run to actually run the project. And you'll see hello world is printed on the screen, and that's because source/main.rs has a println hello world on the screen. It's like a starter hello world binary that we have. This is different from a library. If I delete everything from this folder and if I run cargo init --lib, then I'm initializing a library. So if you look at the files now, the source folder doesn't have a main.rs, but it has a lib.rs, and notice lib.rs just has a function that it exports, doesn't have a main function, doesn't have an entry point, because you never really run this independently. Lib.rs is just a library that other projects or other binaries are going to use. Cool. So there are one of two things you can initialize a Rust project on. You can have both of them together as well. A specific project can both be a binary as well as a library. But generally you have a Rust project is either a library or a binary. It can be both as well in some cases, but generally it's one of these two. So if you look at the CLI is a binary, because there's a bin section over here in cargo.toml. What is cargo.toml? Think of it very similar to package.json. It gives the name, the version, and which edition of Rust you're using as three properties over here. It tells you this is a binary. The name of the binary is Codex, and this is the entry point for the binary. And it has all the dependencies that the project uses. This is different from, let's say, core, which, as the name suggests, probably has the core of the logic. And hence is probably a library and not a binary. It's not something that runs in the end. It's just a library that other people use. So if you go to cargo.toml here, you will see it doesn't have a bin section. It has a lib section, which means this is a library that other projects are hopefully going to use. Okay? Name of the library, version, edition, the details about the library and all the dependencies that it is using. So do we understand the concept of libraries versus binaries in Rust? Some of these projects are going to be binaries, some of these are going to be libraries, some of these are going to be both of them. For example, I don't know which one, but let's try to open TUI and cargo.toml and you will see it has a binary section. It also has a lib section. If you go to TUI/source, you will see it has a lib.rs also. It has a main.rs also. And hence a project can be both a library and a binary as well. Generally, it's either one of these two. So this is the top level repository. It's a cargo workspace, which means it's closer to a monorepo. It has a bunch of packages. Some of these packages are libraries. Some of these packages are binaries. The final binary that you run to run your project is this TUI. That is why when we were in Cursor a while back, if you remember, the folder that I was in was Codex rs/TUI. If you want to run the terminal UI eventually, this is the binary that you are running. But if you look at this binary cargo.toml, you will see it has a bunch of dependencies. And some of these dependencies, for example, codex-core is a local dependency. It's not getting something from the cargo store or, crates.io. It's not getting something from the registry. It is getting this from the registry version 1. It is getting this from the registry version 4. It is not getting this from a registry. It is getting it locally from /core. That is how a binary uses another library. How does a binary use another library or a library use another library? If it's present locally, you can just pass in the path over here, and then codex-core now comes from /core. That means this Rust project over here. So whatever this guy is exporting is being imported in TUI. We understand that. To recap, multiple packages, some of these binaries, some of these libraries. This is the final binary that we're going to run. Before we run this, let's try to just guess what these packages might be. Core, as the name suggests, probably is the core of the Codex logic, the logic that eventually talks to the LLM. This crate implements the business logic for Codex. It is designed to be used with various Codex UIs written in Rust. What does various Codex UIs written in Rust mean? Okay, eventually, we might have a different UI, an actual website or a native application that does the same thing. Right now, we have a terminal UI. In the future, we might have a different UI, and that can also use this core logic. That's the benefit of abstracting the core logic into core. Though for non-Rust UIs, we are also working on a protocol for talking to Codex, there's a specification, so on and so forth. Let's look at source and try to look at a bunch of these files. The first thing you should open in library is lib.rs, and here you will notice there's a bunch of these mod client, pubmod codex, pubmod codex wrapper, so on and so forth. This basically means these are being exported from here. Whenever you see pubmod something, that means the codex.rs file. If you look at source/codex.rs, it's being exported from this package. That is what pubmod codex means. And if you look at this codex.rs, you will see it exports a struct and it has some implementation of functions of the struct. So this codex struct is the main thing, or think of it as a class. It's not really a class, it's a struct, but you can think of it as a class that actually has the business logic to talk to an LLM, get back the response from there, and do something in the terminal. Also in the core module here, you'll find prompt.md, which is the final prompt that we forward to the LLM. So if you search for prompt.md through the code base, you'll find it's referred here in core source config.rs as a constant. And if you look at the config struct over here, it has a load with overrides function where the instruction is set to this specific constant. So the prompt that is finally forwarded to ChatGPT is one you can find in core/prompt.md. If you look at it, it's basically describing the problem, which is, please resolve this user's task by editing and testing the code files in your current code execution session. You are a deployed coding agent. Your session is backed by a container specifically designed for you to run. I'm unsure if this is true. If it is backed by a container, I could be wrong, because it's running locally on my machine. I don't think it's necessary that it's running inside a container, but I could be wrong. The repos are cloned in your current working directory, and you must fully solve the problem, so on and so forth. This seems like a copied prompt from somewhere else, maybe. So OpenAI has like other services that let you do cloud projects, like you can create a project in the cloud similar to Devin. And this probably seems like a prompt from there. I could be wrong. It still might work, or probably does work. But unsure if technically things that are mentioned here are correct. Cool. Similarly, there are a bunch of others. There's exec, that's probably for executing final commands. There's interactive, which I'm sure there are yeah, they explain it here. Core contains the core business logic for Codex, which is, basically the main thing that's interacting with the LLM and sending back responses. Interactive is a CLI comparable to the TypeScript Codex CLI. And then there's something called CLI, which is a CLI multi-tool that performs aforementioned CLIs via subcommand. I don't know what this is. And TUI, which is the one that we're going to focus on, which is the CLI that launches a full screen TUI built with Ratatouille. So what I can understand is this is probably a slightly milder version of a CLI, which doesn't have the fanciest UI. And TUI launches a full screen terminal UI with the help of this framework called Ratatouille. So Ratatouille is a framework, a Rust crate for cooking up terminal user interfaces. So if you want to show a very pretty user interface inside a terminal, is what you use Ratatouille for. Their TypeScript repository uses something similar. There's this thing called ink in npm, or an npm package called ink, which lets you do the same thing in TypeScript, which is paint a very nice call it interface or terminal using the specific library. And similarly, Ratatouille is the same for Rust. If you remember a while back, we looked at TUI and we tried to run it locally. When we did run it locally, we were able to see the project running. And if you look at its cargo.toml, it at least locally seems like only uses Codex core. So in the end, we're going to be contributing where? We're going to contribute to hopefully TUI, which is dependent on another local crate called core, which has, the core of the Codex logic. So let's call it Codex core. And that's the Codex core might be dependent on something else. Let's see. So if you go to Codex core and look at the dependencies, probably is dependent on CLI or something. Let's see. // It's only dependent on one package called Codex apply patch, which we can look at what it is. But mota, if we're making any changes today, we're making them either here or here. If we're making UI changes over here, if we're making functionality changes, we'll be making them over here. So hopefully you have a high level structure of the code base. In the end, we have a bunch of packages. The ones that we're going to be dealing with would be core, that has the core Codex logic, that Codex as in, not CODECS, I mean Codex, which is CODEX, that interacts with the LLM. And then TUI, that primarily is a front end, but not a React front end, not a website. It's a terminal front end for our application. Cool. Let's spend some time looking at some issues or try to figure out some issues ourselves. I'm sure there's a lot of incompatibility between Codex RS, which they've mentioned here as well. The Rust implementation is materially behind the TypeScript implementation. So let's see if there's something we can provide and bridge between the TypeScript implementation and the Rust implementation. Or if there isn't, then we'll try to look at some of these issues and try to solve it. Let's get into that in the next section. All right. Finding issues was a process. The thing is, issues in this repository are very, they're more user queries or less features basically, and most of them, not most of them, all of them directed towards the TypeScript repository, which is something we are not trying to contribute today. We're contributing to the Rust repo. So I spent around an hour trying to figure out issues kya ho sakta hai. Finally, I've figured out 3 of them. Let me explain all 3 features issues that we should fix. One of them I've been able to fix. 2 of them I don't have time for. The video release is in an hour. So let me take you through the steps of how I've solved the first one, and then other 2, you'll probably find the code on GitHub whenever I do, or if some of you want to pick up the issue, that's fine as well. But let me quickly take you through how I've debugged one of the issue. What are the 3 issues? Let's kick things off there. What are the 3 issues that are good to solve? So the way I found these 3 issues or features was I opened the TypeScript. Oh, oopsie daisy. I opened the TypeScript implementation on the left. So, or the Rust implementation on the left. I opened the TypeScript implementation on the right. So This is the TypeScript implementation. This is the Rust implementation. Feature number 1. If I go to the TypeScript implementation and say, please run the pwd command, you wouldn't do that in the real world. You would give it, a real thing to solve. I just wanted to show what happens when the AI directs to run a command. And in this case, you can see first command is the current first output. Okay, this is the command that you need to run. Then command.std out with the exit code of the command and the time that it took is the second output. That's what you see here. And then whatever Codex response, which is the current working directory is this, that's the third response. That's not true here. So let me stash my code and then rerun this cargo run. You will notice if I ask this guy over here to run pwd command, there are visually a lot of differences. This is the simplest issue to solve. Visual issue being, notice here the user is inundated to the left and every AI command is inundated to the right. That doesn't happen here. User is on the left, command is on the left, and notice command and command std out are separated. Here command and command std out are not separated. The final response of the AI for some reason here is this. Again, this might be a bug. Maybe the AI is returning the whole thing, but the Rust repo is snipping it out. I don't think that is true. I think the prompts of both of these are very different, which is causing the TypeScript repo to return some context along with the directory and the Rust repo to only return the directory. Either way, issue number 1, simplest one, is to make sure everything is inundated to the right and the splitting of command and command std out happens. That way, this becomes feature compatible with TypeScript, which is what we're trying to do anyways. The Rust repo should become equivalent to the TypeScript repo. Issue number 1, very simple. Whenever commands are running, or all AI commands should be right inundated. So it's more of a UI issue, but this isn't standard UI. It's not very easy to fix because all the UI is written in Rust. So we have to understand how you write. It's just very weird writing UIs in Rust. If you've ever tried Tori or some other framework, that's a difficult bit here. Even though the feature seems very simple, it's not as easy to implement. That's feature number 1. Feature number 2, one thing that exists in the TypeScript repo is I can press the up arrow key and I get the previous command, which is something you would expect. If this is a CLI, that almost looks like a operating system or a bash script, or this is where I can run my commands. If I press the up arrow key, I should see my previous command. If I press the down arrow key, I should go back to the newer commands. So this exists in the TypeScript repo. Does not exist here. Probably is a very low priority feature at the moment because this repo is just started 4 days ago, right? So doesn't take very high priority, but also very hard to fix because you now need to maintain a history of commands that the user has run in this specific session. So that's issue number 2. Issue number 3, which again might seem easy, but probably when we implement it, it'll be a little difficult, will be this. Hi there, when I send a command, I can press escape twice to exit it. I repeat, when I ask the AI to do something, while it is thinking, I can press escape twice. And you also see this, warning over here. Press escape twice to interrupt. The same thing doesn't happen here right now. If I press hi there, pressing escape does nothing. The reason this is mildly difficult is because you have to interrupt the AI command, which, that means we might have to dig into the code base of Codex, not just the UI, not just the TUI module, but also the core module that exists in Rust. May or may not be true, we'll see. But these are the 3 issues to solve. Difficulty wise, inundating is the easiest one to solve. Then maybe this one, which is pressing the escape key. Then the most difficult one will be pressing the up arrow key to see the old commands, down arrow key to see the new commands. Difficulty wise, these will be the 3. Feature wise, I don't know, just pick and choose which one you think is most useful. I think neither of these are P0 issues. Neither of these are causing any UX solve for a user that's really big. But all 3 of them will take you to the Rust code base in depth. Probably the up arrow key and down arrow key will be the one that has the most lines of code when it comes to the changes, and also probably the most difficult one to figure out. So ये 3 issues solve करने हैं, guys. We have 1 hour. Most probably I'm just going to solve one, which is the indentation one. We'll see if we get time. I'll try to at least describe the path of how to do it, or I might do a live tomorrow where I cover the other 2 issues. Or you might just see my PR on GitHub, one of these 3. Okay. The next section, let's fix the first issue. The issue is the TypeScript repository has some indentation to the right of all the AI commands. That is not true for this guy. The formatting is also different. Command and command std out are separated. That is not true over here. Let's get into the code next. I think I've already coded it. Let me show you the final thing. I see a bunch of warnings, but I git stash pop. I already did this, even though there are a bunch of warnings I need to get rid of. So when I press or run the command, please run pwd. Notice the user command is on the left, but the AI command is on the right, and also command and command.std out are separated, which is exactly what happens over here. Command.std out and Codex, command.std out and Codex. So I fixed it. I still have to take you through the fix. So let me push a PR maybe, and then I'll take you to the diff over there. Or maybe I probably should explore the code base. So let's explore the code base and try to understand the change next. All right, just to recap the first issue that we are solving right now, if I ask the Node.js implementation, please run the pwd command. Even though you wouldn't ask this to an AI ever, you'd ask it to add a feature, and in the process, it'll run a few commands on your machine. But if I just force it to run a command for now, the output looks like this, which means the user messages are on the left, and the assistant messages and all the commands that it ran through the assistant are on the right. That is not true over here. If I, in the Rust implementation, write, please run, oopsie daisy, please run the pwd command. You will notice, there's some log over here. I think this is intentional for now. This task one started, but we can eventually remove it. And the command is on the left here. It's not annotated to the right. You don't see a separate section for the command and a separate section for the output. The output and the command will appear right next to each other. That is not true over here. Over here, command is a separate section, output is a separate section, and then the final response is a separate section. Here, command and the std out of the command, the response of the command, are both in the same line. These are the two things we have to fix. The diff isn't too much. I've already created it. It's just two files in which there is 23 lines of code that have changed. Reaching there is very hard. So let me quickly take you through how I navigated the code base and reached the right places to fix. We are currently working with TUI/main.rs. This is the entry point to whenever I run cargo run in the TUI folder. So I'm in the Codex/Codex/Codex/RS/TUI folder. That stands for terminal UI. And here, when I run cargo run, what is happening? The main function over here is running. There are a few things that you need to know before you go through this code base. One is, let me quickly write them down. You should read about them independently. Async runtimes in Rust, specifically the one that's used here is Tokyo. Spawning, not really threads. What's the right word for it? Let me write threads for now, but not really threads. Asynchronous context switchable threads, whatever they're called, in Tokyo. Then message passing in Rust, so multiple producer, single consumer. And those are the difficult bits. Other than that, you of course need to know the basic syntax of Rust. But these three you need to know before you can understand the code base better. Nothing too crazy. If you have written Rust code, these are standard things that you're anyways going to learn. Cool. Okay, this is the main function. Let me try to explain it, as very simple, 101 teaching to a 5-year-old. The first thing is going to parse the CLI. So in the end, the user, when they use the application, they're going to use it like this, right? Something like Codex, and then they can pass in a few flags. For example, the model that they want to use. Do they want to use GPT-3? Do they want to use O1? So on and so forth. So all of these flags can actually be parsed into this CLI struct, which has the prompt, which in our case is picked from prompt.md. I don't know what images is, optional images to attach to the initial prompt, if in case you want to attach images to the initial prompt. The model that we want to use, which includes things like GPT-3, GPT-4, O1, so on and so forth. So approval policy, whether or not you want to ask for approval, or do you want to force the AI to do whatever you want on your machine, so on and so forth. So all of these can be represented by using these macros. The M short flag, which means, if I'm running the CLI, I can give the -m flag and specify the model. That is what will be sort of parsed to this model attribute over here. So this is a bunch of macros that this library, whichever is exporting args, which most probably is, some, let's see, what is this library? It's called clap, which I think is the right one. So if you search for clap on cargo or whatever crates, clap is probably a CLI library, a simple, efficient to use, fully featured command line argument parser in Rust. So this project also uses clap to parse the CLI arguments into this CLI struct. So by the end of it, you have access to a CLI struct which has your model, your prompt, so on and so forth. Then we call the run_main function. If you don't understand why there's a question mark here, again, basic things, syntax in Rust, and maybe another thing to add to the things to know would be exceptions in Rust. And how do you do exception handling in Rust? Basically, that's what the question mark here represents. Run_main function, it checks if a few environment variables are set, creates this config object, which has a bunch of things, does a bunch of logging, so on and so forth. In the end, it calls a function called try run Ratatouille app. So this Ratatouille app is the final front end that we're running. Under the hood, it's calling the Codex core module, this core module that exists over here. But we're primarily writing the front end code here. So think of this like a React project. So the try run Ratatouille app function calls the run Ratatouille app function, which if you look at it, in the end calls something called app.run. So there is this custom struct that we have created called app, which exposes a function. Again, this might be a little complicated to digest if this is the first time that you're seeing it, specifically, this syntax and maybe even this syntax, the what are generics, what is a sender, what is a receiver. I'm not going deeper into it. We also don't need a bunch of this. But eventually, when you are going through this code base, you will have to understand what are, senders and receivers, what is, how do you do message passing in Rust, which is similar to channels in Golang, if you've ever done Golang. But basically, since this is a multi-threaded process, threads need to share some data amongst them, and there are various ways to do it. One of them is message passing. That is what this sender and receiver is used for. Chat widget is basically this UI that you finally see when I run cargo run. This whole UI is sort of stored in a struct called chat widget. That's what this is. And app state probably is, chat probably has the history of chat, things like these, I would assume. Let's see. App state is the screens that you have. Again, I'm learning this on the go as well. I've never used this library before. TUI, the library that we're using for frontends. But now that I look at it, app state is the two states or the two frontends that you can have, the two pages that you can have. So think of these like top level pages in a Next.js project. We can have a chat page, which is, this thing right here. And then we can have a Git warning page, which probably shows up if I run this in a non-Git repository. So let me try that out. I'm just curious to try it out now. Let me remove Git from here. And if I now go to Codex rs/tui and run cargo run, hopefully I see the GitHub warning screen. There you go. So warning, not a Git repository. That's the second screen that exists. So we switch between these two screens based on, whether or not the user is inside a Git repository when they start the project. But, by default, hopefully when run gets called, which is, this function right here, that's the function that we saw was getting called in the last slide or the last file. Here we probably check somewhere which which page to render, probably after this. But even before that, what are we doing? So here is again we're doing message passing here. We're sending a redraw event that we're catching immediately after. This is an infinite loop sort of that we're running, that is receiving all of these events or reading all of these events on the channel, if you understand channels in Golang or Rust. So here I've produced something to the channel. Here I'm receiving it, and the event that's produced over here is redraw, that is getting caught over here, that calls draw next frame, that basically tells the TUI framework to re-render. Similarly, there are a bunch of other events that we can catch on this message parser. Key event, that's whenever a key is pressed, if the C key is pressed, when control is clicked by the user, that means the user is trying to interrupt or close. When the D key is pressed, whenever the user's control is present, that means the user wants to exit, so on and so forth. Then there is scroll. Whenever you scroll up over here or scroll down over here, is when you scroll up or scroll down, these events are triggered. So on and so forth. Whenever you receive an event from Codex, whenever Codex tells you, okay, hey, a command has run, or if I press hi, finally the AI is going to tell me the response of hi. That comes over here. That's what Codex op means. So on and so forth. So Codex op seems like the right place for the first change, right? Somewhere in Codex ops, we receive a response from somewhere that calls this chat window.submit op function, that calls this that does a codex op.tx.send, which basically means this is another message parser. I am sending things on this message parser. I have to now find its receiver, which exists over here in chat widget.rs. So here there's the receiver, and every time I receive a message over here, we call codex clone.submit.await. So let's look at the submit function. What does that do? Probably sends thing to Codex. The question is, how do we receive things from Codex? Yeah, this is for submitting the events. That's probably this. While let OK event equal to codex.next event. So Codex is the core package that we had. Here we are sending things to Codex through a message parser. So one thread is getting those messages and forwarding them over here. This sort of code is constantly reading things from Codex. Whenever the AI returns something, eventually the control reaches here. And if you look at it here, what are we doing? We are again sending or passing it via another message parser called app event. So where is the app event receiver? It is over here. And here, if you look at it, it's the same one, Codex op. What's the event? It's Codex event. So that's this thing right here. Codex, also Codex operation is me sending data. Codex event is me receiving data from Codex, which is, our agent or whatever, the thing that's talking to the LLM. This finally calls a chat widget.handle Codex event, which based on the event, is it an agent message? Has the agent responded with something? And if the agent has responded with something, that means we need to add agent message to the conversation history. So hopefully this is the function that is pushing the message somewhere that eventually gets rendered on the screen. So this add to history just pushes something to the history object, and that's probably what is being rendered over here. This is just the history of all the messages that we have. 709, I missed a call, that's fine. So the question is, we don't want agent message. What are we worried about? We're worried about exec approval request, exec patch approval request, exec command begin, exec command end. What do we want? Whenever a command executes, for example, this one right here, pwd, whenever it execute, when its execution finishes, we want some extra separation here. Right now, if I call what is the current working directory, this goes to an LLM gets the response, LLM tells कि यार ये command run करनी है अब. pwd is the command that we have to run. That message eventually reaches here in the exec command end sort of event handler. And यहाँ पे we do a conversation history dot record complete exec command function. So this record complete exec command function right now iterates over the history. If let us cell for cell in self.history.iter mutably, if already this thing cell, if already cell equal to history cell.new complete exec command, and that is it. This should push this event somewhere, I would assume. Cell.history, or it's just updating the cell. Okay, so when you send the std out command, I guess, whenever this command is sent, a cell is already created, and this is just enriching the cell with exit code, std out, std and the duration that has happened. So again, this is just enriching an object, just how we were enriching a conversations object. This is or a history object, the same history object has been enriched now. So let's just look at self.history, which is a vector of history cell. So all of these things that you see over here, a codex message, a user message, a std out command, another codex message, are all a vector of history cell, which means, a vector of either user prompt or vector of, it might have a user prompt, might have an agent message, might have a active exec command, that means a command that's currently active, or a completed exec command, that means that is finished. Now what we want is, if we're rendering a completed exec command, it shows up slightly prettier. It has command and then the actual command, and then has command.std out, and then has the final thing. So we need to now figure out where are these things rendered. So where is this rendered? History cell, history. So let's see where all history is used, and it's used in a lot of places. Render ref is a function that uses history, and that might be it. Number of lines is this thing. So this is not that. It just calculates the number of lines, which it's probably uses for scroll or something. But if I keep scrolling in this render ref function, is where I see, okay, if the scroll position is 0 or max, that means the user is at the bottom of this scroll, is when some things get rendered, or all the history gets rendered. Self.history.iterator.reverse, I go through the history and push something to this array called visible lines. That's the lines that are currently visible in the viewport. As I scroll up, the lines change. As I scroll down, the lines change. But this is the thing that is actually rendering what lines to finally show on the screen based on the scroll. If the user has scrolled up a bit, then start line is found out through some algorithm, and some specific lines are pushed to visible underscore lines. If you have already scrolled to the bottom, then visible lines has something else. Eventually, these visible lines are probably passed somewhere to this framework to actually render. So if I search for visible lines, we create a paragraph, which might be similar to a paragraph in HTML if you've ever created a p tag, and that is what we render in a specific area, which is this area right here is basically rendering a paragraph which has all of these lines one after the other. Okay. Now what is the first change we had to make? We had to move these to the right. We had to move user to the right. We had to move command to the right. If the message that the user is sending, here we're pushing something to the visible underscore lines array. The visible lines, which is this line, and then this line, and then this line, and then this line, and this line, are being pushed over here. But we want कि यार line का जो type है, if you look at what lines were, or self.history, this history cell was of user prompt or agent message or completed exec command, so on and so forth. It's of one of many types. So based on this type, we want to render it a little to the right or at the same place. ये चीज समझ आ रही है? If I history.iter, there you go. No, that's not the one. This is the one. Each one of these cell has lines, and is of a specific type. So what we want to do is we want to match the cell, and if the cell is of type exec command has been executed, or if it is of type an agent message has been sent. I mean, this AI helped us a lot here because I already wrote this code a while back. But basically, what has happened is we're not simply pushing the line. We are either padding the line a little bit. हम उससे पहले कुछ डाल रहे हैं. If the message type is of type completed exec command or agent message. I know it's a little hard. Like UI shouldn't be this hard, but unfortunately, this isn't React and we're not writing JavaScript. So unfortunately, the place where visible lines, which is the lines that are currently visible based on the scroll, wherever this is being populated, is where you have to check कि यार किस type का message render हो रहा है. Is it of type agent message or is it of type completed exec message? And if it is one of these two, we need to append some extra things to the beginning of the string. That is what these 3 lines of code do. How you should just explore this line struct, and you will see the line struct has something called spans, which is, the individual elements that are being rendered, which, this could be a line. So user is a span, hi is a span. And similarly, what do we want? We want कि codex से पहले एक थोड़ा space वाला span आ जाए, and hello world से पहले थोड़ा space वाला span आ जाए. We want all of these lines to have a extra space span before them. So, what have we done for that? We said if this specific cell is of type this or this, then, add another span, which is a raw span which just has space. And, uske baad add the spans of, that exist in this line. Is line mein jo tha already, if this line had codex, to usse pehle space dal do. If this line had hi, how can I help you today, usse pehle space dal do. This might break if you have a really long message from the AI. I could be wrong, but I think if the message is really long from the AI and it wraps to the second line, I think it'll again go to the left. I could be wrong, but I think that will happen. We'll see. But that is what these 3 lines of code do, and we do it in both the places. We do it when the scroll position is maximum. That means when the user is scrolled to the bottom. We also do it in the other case. Initially, I did it only in one place, and I could see as soon as I scrolled up, everything broke, and when I scrolled down, everything was fixed. So that's all the change that I made. If I restart the project now, and if I run whatever, explain this project, daisy, seems like it crashed. Oh, not a Git repository, but that's fine. Yes, to continue. Explain this. I mean, this looks wrong. Even the codex message is right padded. Why is that? Match cell, history cell, complete exec command or agent message. Then add a space, else do nothing. That looks right to me. And in the else, I don't know what I've done in the, oh wait. That looks right. And what have I done here? I have not done the same thing over here for some reason. Did I forget to do it? Maybe I did. So what do I have to do to remove this? And I have to re-add, something similar to this over here. Yeah, that looks good. Unsure if that is what broke it. But also let me initialize an empty git repo so we don't see the warning. Codex rs/tui and then cargo run, and you will notice, hopefully this time, yeah, let's send a message. Run the pwd command. Oh, codex is supposed to be right padded. So welcome to codex is probably the first message shouldn't be right padded. Does that happen over here? This doesn't even have a initial message that says welcome to Codex. The JavaScript SDK this guy does. So it is right padded now because all Codex messages we have right padded. Probably the first one shouldn't be, but at least for the rest of the ones, the user messages are left padded and everything else is right padded, which is exactly what we wanted. So if I send another message, run it again, my message is left padded, but the response from the AI and the commands that we're running are all right padded. And scrolling seems to work as well. So that was the first fix, which was right padding the thing. If you look at the final change that I did on GitHub, pretty similar in conversation history widget.rs. I, rather than directly pushing the line, I checked whether or not the cell is of type this and this, and if it is of type agent message or completed exec message, is when I appended a extra space to the beginning. Else I did the same thing that was being done before. Cool. And I did it in 2 different places. One where the scroll is at the bottom, one where the scroll is not at the bottom. Cool. That was a simpler one. I guess that was the difficult one. The simpler one was this one, which is command and command.std out should be separate. So this, how did I figure this out? I have no idea how did I reach the right file. If I keep exploring, I'll reach there again. Let me just take you through the diff, which was in history cell.rs. So it's still, I'm still not explaining how I reached this file, which was basically through a lot of trial and error and finally reaching this file. But in this file, somewhere here, yeah, somehow through the commands I reached, new active exec command and new completed exec command. Okay, this function is called whenever a execution command is completed. And I could clearly see, they're creating a new line here called command, which is magenta. And then they're pushing this line, and then they're also pushing, the final command that ran followed by a dollar. So dollar command, that is exactly what I saw over here. Okay, there was command in purple and then there was dollar command. I know I want to change this to command in purple, dollar command, and then command.std out with the code 0 second duration 0 second. जो यहाँ पे है अभी, I need to move it below. So what I did was I added another line called whatever sub_title line, let's say, which will be command.std out, and this will have the code execution time and everything. I removed the code execution time from here. That was the first thing. I'll push that to the lines that we have to render, and then we will push the final response, which I guess anyways is happening after it. So line.push, this is probably the raw response that comes. So that should be good enough. I just added this in the middle, which is command.std out, so that between this and this we have a command.std out. I also added an extra line here just to make sure there's more space and breathing room. But let's test this out. If I run this again and run the command, come on, quick, run pwd here, you will now notice user command followed by command pwd command.std out, the final std out, the same thing that we see over here. There's more breathing room here, there's less breathing room here, but you can just add more lines, right? You can do a lines.push empty string, something like this, to just add an extra line wherever you want. So if I want it after the command, I want it after this guy, I can keep doing it. So if I now do it, you'll see more breathing room. Get the idea, pretty simple stuff. Let's try it out. Run pwd, and now you will see one, things are right aligned, which is what we wanted, and two, there's a little too much breathing room now. Command and pwd should have some breathing room, and then there should just be one line, and then command.std out, and this should have some breathing room, not so much. Easy to do some trial and error and fix that. Beautiful. That was issue fix number 1. The official fix is over here. I'll link this in the description. I've not PR'd it. It just seems like too simple of an issue, and probably not high priority for them to spend effort over here. Maybe if I do a few more, for example, there are 2 more issues that I described in the last section, then might make sense to do a chunky PR. But I might do this one as well. I don't know right now. Cool. Hopefully you learned something new from this video. To recap this video, we were going through, my goal was a week ago to go through the TypeScript SDK or whatever, not the SDK, the CLI. But then this morning I saw they've migrated, or they're trying to migrate to a Rust CLI, which seems like a much more interesting challenge. It's very hard to build UIs in Rust, period. It's even harder to build terminal UIs in even JavaScript also, but specifically in Rust to 100%. That's what we migrated through today. As you saw, there is like a lot of manual process of figuring out what happens when you scroll up, what happens when you scroll down. But unfortunately, this is how Claude code was built. Unfortunately, this is how you might want to build an application like this. That's how OpenAI has built it as well. We'll see if it has adoption. I'm unsure right now, but it did get 20K stars in like 10 days. That tells you something. In the worst case, you learn something from it. You might become a contributor to OpenAI if you really want to, if you really go all in here. Like I would have, if I had time, I might have time, I might be contributing more here, specifically to the Rust repo, because I think that's where they'll be spending most of their efforts as well. That's also where it'll be hard for them to hire. But again, these are all speculations from my side. That's pretty much all I had for this one. Let me know if there is another issue you want me to solve. I'll probably live stream tomorrow or day after, and happy to look at it over there live on a stream. With that, we'll end it. I will see you guys in the next one. Bye bye.